Let's start with the pioneers. Back in 1900, Max Planck came up with a groundbreaking idea: energy is quantized. This means it's emitted or absorbed in little packets, which he called quanta. Then, Albert Einstein, in 1905, used this theory to explain the photoelectric effect, suggesting that light itself is made up of particles called photons. Fast forward to 1913, Niels Bohr introduced his model of the atom, where electrons orbit the nucleus in quantized paths. And in 1927, Werner Heisenberg formulated the uncertainty principle, which tells us that we can't know both the position and momentum of a particle with perfect precision. The more precisely we know one, the less precisely we can know the other. Now let's talk concepts. Ever heard of wave-particle duality? It's this mind-bending idea that particles like electrons can exhibit both particle-like and wave-like properties. Think of the double-slit experiment, where electrons create an interference pattern just like waves do. Then there's quantum superposition, famously illustrated by Schrödinger's cat. A thought experiment where a cat in a box can be both alive and dead until someone looks. It shows how particles can exist in multiple states at the same time, until they're observed. And quantum entanglement? It's what Einstein called spooky action at a distance. This is when the state of one particle is instantly linked to another, no matter how far apart they are. Now, why does any of this matter? Because quantum physics isn't just about theory. It's the backbone of many technologies you use every day. From the semiconductors and transistors in your smartphones and computers, thanks to quantum mechanics, to MRI machines which use quantum mechanics to peek inside the human body. And the future, it looks even more exciting. Imagine a quantum internet, where information is transmitted through quantum entanglement or quantum artificial intelligence, which could solve complex problems at an unbelievable speed. We are also looking forward to room temperature superconductors, which could transform everything from energy transmission to magnetic levitation technologies. But quantum physics isn't just about new gadgets and gizmos. It challenges our very ideas about reality. It suggests that at a fundamental level, the universe isn't deterministic, but probabilistic, and that leads to some pretty wild philosophical implications and various interpretations, like the Copenhagen and the many worlds interpretations. And one of the biggest quests, combining quantum mechanics with general relativity to create a unified theory of everything, quantum gravity. So whether you're a student, a curious mind, or someone fascinated by the universe, quantum physics offers a glimpse into the most fundamental aspects of reality, challenging our perceptions and promising a future full of incredible possibilities. Let's dive deeper into the 6 fundamental laws that govern this mysterious world. First up, imagine if you could be both a solid object and a wave of energy at the same time. That's exactly what particles like electrons and photons do. Depending on how we observe them, they can behave like tiny particles or spread out like waves. For instance, light sometimes acts like a wave, creating beautiful interference patterns, and other times like a particle, with photons hitting a detector one by one. Next, think of a staircase. You can stand on one step or another, but never in between. In the quantum world, certain properties such as energy exist only in specific discrete values. Electrons in an atom can only occupy particular energy levels, much like how you can only stand on certain steps of a staircase. Then there's the A principle tells us that there's a fundamental limit to how precisely we can know certain pairs of properties of a particle, like its position and momentum. The more accurately we know one, the less accurately we can know the other. It's as if the universe has built-in fuzziness at the quantum level. This mind-bending principle states that a quantum system can exist in multiple states simultaneously until it is measured. It's like saying a cat in a box can be both alive and dead until you open the box and check. This superposition is at the heart of many quantum phenomena and allows particles to exist in a combination of states. Now let's talk about when particles become entangled. The state of one particle is instantly linked to the state of another, no matter how far apart they are. If you measure one particle, you instantly know something about its entangled partner. This connection happens instantaneously, even if the particles are separated by vast distances. Einstein famously called this spooky action at a distance. Lastly, in the quantum world, the outcomes of measurements are inherently probabilistic. We can only predict the likelihood of finding a particle in a particular state, not a definite outcome. This probability is determined by the wave function of the particle, which tells us the chances of finding it in different states. So there you have it. The 6 laws of quantum physics that shape our understanding of the universe. From the dual nature of particles to the mysterious connections of entanglement, these principles challenge our perceptions and open up a world of possibilities. As we continue to explore and question, who knows what incredible discoveries lie ahead. Now that we've explored the 7 essential elements of quantum physics, you might be wondering, how does this abstract and counterintuitive science impact our everyday lives? Let's dive into some real-world applications of quantum mechanics that are revolutionizing the way we live, work, and play. First up, let's talk about quantum computing. Unlike classical computers that use bits to process information as 0s or 1s, quantum computers use qubits, which can exist in multiple states simultaneously thanks to superposition. This allows quantum computers to solve complex problems at speeds unimaginable with current technology. From drug discovery to cryptography, quantum computing holds the promise of breakthroughs across various fields. Next, we have quantum cryptography. This technology leverages the principles of quantum mechanics to create virtually unbreakable encryption. Through quantum key distribution, any attempt to eavesdrop on a message would disturb the system, alerting both the sender and receiver. This makes quantum cryptography a powerful tool for securing sensitive communications, from financial transactions to national security. Quantum mechanics also plays a crucial role in the development of semiconductors and transistors, the building blocks of modern electronics. The behavior of electrons in these materials is governed by quantum principles, enabling the creation of smaller, faster, and more efficient devices. The smartphones, laptops, and other gadgets we use daily owe their performance to advances in quantum physics. Another fascinating application is in medical imaging. Techniques like MRI, magnetic resonance imaging, rely on quantum principles to provide detailed images of the body's internal structures. By understanding and manipulating the quantum states of atomic nuclei, doctors can diagnose and treat medical conditions with greater precision and accuracy. Lastly, let's not forget about quantum sensors. These highly sensitive devices can detect minute changes in physical quantities like magnetic fields, temperature, and pressure. They are used in various industries, from oil exploration to climate monitoring, and even in developing new navigation systems that don't rely on GPS. As we continue to unlock the mysteries of the quantum realm, the potential for innovation and discovery is boundless. From enhancing our daily lives to pushing the boundaries of science and technology, quantum mechanics is at the forefront of a new era of possibilities. Thank you for joining me on this journey through the quantum world. Until next time, stay curious and keep exploring.